Hi there. This is the Design Your Physician Life podcast. Welcome to this episode brought to you by the Max Salary Mastermind, a personal and professional development program for physicians who want to learn entrepreneurship. And talking about entrepreneurship, today we have an amazing entrepreneur. Her name is Dr. Rachel Draelos, and we're going to be talking about building a healthcare AI startup. Are you ready? Let's go.
Welcome to the Design Your Physician Life podcast, where you will get excited about being a physician, learn the tools that can help boost your success, and great tips from successful doctors. Join us to unlock the keys to an amazing physician life. And now, here's your host, Dr. Myrdalis Diaz-Ramirez.
Hey guys, welcome to another episode of Design Your Physician Life podcast. Today is I cannot be grateful enough. This is the second time that Dr. Rachel Draelos is here in the house. So thank you for coming for a second time to give us more information about artificial intelligence.
Thanks for having me. I'm excited for it.
Yeah, how have you been since we last saw you? You've been very busy, right?
Yeah, I've been very busy. Things have been great. It's an exciting time with working on my business. We've recently released our new product, and it's been just good busy, I would say.
We talk a lot about it because it's a product for physicians to use. So Dr. Rachel Diaz is the CEO of the health tech startup CyDoc, and she was here before talking to us about artificial intelligence. And today we're going to go a little bit deeper into what her product is. We're going to go into some basics of artificial intelligence. Then we're going to move into some information about how to create data sets, and then some funding for your company. So let's go one by one. Tell us about your recent release and how is it helping physicians, nowadays?
Absolutely. Our first product is a smart patient intake form, and the goal of the product is to help with note writing. So the way it works is patients can fill out a questionnaire on their smartphone or a tablet. This would be before their appointment, either at home or in the waiting room. And then we have a system, an AI system that uses medical reasoning to ask the patients questions in the form about specifically why they're coming in. So if someone's coming in for a diabetes follow-up, that'll be a totally different line of questions than if they're coming in with, for example, headaches. And then after we go through this Q&A with the patient, which just takes them a couple minutes to complete, we'll take that Q&A data and transform it into basically what could be the HPI or subjective section of a medical note. And that can help the visit go more efficiently because a chunk of the history is already written down. And then it can also help with note writing because there's a piece of the note that's already been drafted out before the patient even starts the appointment with you. So we're very excited about being able to streamline things and help with the very large burden of administrative tasks that often fall on physicians' shoulders.
That's amazing. That's exciting. So for those of you who don't know about Dr. Draelos here, she's a physician and she also studied computer science, and she has a lot of information and experience in this area of artificial intelligence. And one of the things that she's thought about is the patient flow and how it affects the physicians to make things more efficient. And there was your inspiration, as I understand. So that's amazing. Can you tell us a little bit about your clients right now, where you've deployed your product, how has it been accepted by the physicians that you've approached and sold it to?
Absolutely. So right now for our clients, we're focused on family medicine and obstetrics and gynecology private practices. We're also considering in the near future adding orthopedics as well. So those are our main target areas. And that's due to just a lot of research that we did that showed there was a lot of demand for help with note writing in especially those settings, but we do have a very adaptable framework. So certainly, if you're a physician in another area and you're interested in trying this out, we're always eager to expand into new specialties. And it's been really exciting to get the real world deployment and start getting feedback from doctors and patients. We recently released a new upgrade to our product based directly on that feedback that helps make the process of matching patients with particular topics for their visit a lot more efficient. So that's something we're super excited about because one of our core guiding principles is having really intuitive user interfaces. And we constantly want to make our product more efficient, easier to use, and try and make it maximally time saving.
One of the challenges that I've seen with products, not for you, because in your case, it's like entering the data and then producing a note. But there are some other levels of this. Like if we wanted to think about, what a next level of this product could be something that the patients enter some data and then you have some potential differential diagnosis, right, with the data that the patient has entered. But then you get into more of the diagnosing and treatment of patient, which requires FDA approval, and then it gets a lot more complicated there. However, have you thought about any elements of that in any way, shape, or form for your product?
I have thought about it. It's been a comment that some people have made to me at different conversations I've had along the way. Oh, hey, is your product going to do any predictions of what does this patient have or how should they be treated? And at least for now, I'm not planning to go in that direction. One factor there is the FDA approval. Anytime you, as you said, anytime you get into diagnosing patients with AI, then you have to go the FDA approval route, which takes, a lot of time and energy. And then the other piece of it is that just in terms of the conversations I've had, the impression that I've had from most of the people I've talked to is that coming up with a diagnosis for a patient and coming up with a treatment plan is something that most doctors enjoy doing and not necessarily something that they want to have taken away from them with technology. So that's not going to be one of CyDoc's focuses, although there are companies out there that are working on things like that. And it is certainly an area of AI where there are research papers that, people publish research papers on how can we predict what this patient has. So ultimately the direction that I'm planning to take CyDoc is creating what I'm calling an AI native electronic medical record that as a whole, as a piece of software, will automate away things that people don't like doing, like documenting or billing or administrative tasks.
Well, one of the things that we talk is about AI, right? AI. And AI stands for artificial intelligence, which seems to be more romantic or more commercial, more sellable than machine learning. As I understand, AI should be, like if you go to the purest of the terms, people will say AI is when you're dreaming or thinking about it, and when it becomes reality is more machine learning. But regardless of the nomenclature, I love to discuss some types of AI because we've seen a lot of AI, and you're using different AI than AI that's in the market right now for many other things like generative AI. There's the one that explains things of AI. So tell us a little bit about the different types of AI that, as somebody who doesn't know anything about artificial intelligence.
Sure. So AI is, as you said, it's kind of this romantic term. It makes us think about science fiction and intelligent robots and everything. And it's really just it's a huge umbrella term for any computer program that displays some kind of activity or behavior that seems smart. So any software that appears to exhibit some kind of intelligence, regardless of how that software is built, that can fall under the umbrella of AI. And there's a whole bunch of different ways that AI can be broken down. So one way of breaking it down is strong AI versus weak AI. So strong AI would be like the science fiction type of thing. Like if you watch Star Trek, like Data would be strong AI. And that's this whole idea of, some kind of sentient AI that kind of acts like a person and can do everything a person can do. And then there's weak AI, which is more grounded in the world that we live in. And that's AI that's targeted towards solving a particular task. So for example, a self-driving car, the AI systems in that would be considered weak AI because they drive a car, but they're not, figuring out what to cook for dinner and then cooking dinner. That's their focus. Or a diagnostic system that will, for example, it'll take in a medical image and then it will predict some of the abnormalities in the image. That would be another example of weak AI. And then we can also break AI down into different categories of methods. So when most of the time in the news these days, when you hear about AI, it's typically talking about machine learning methods. And this is the subcategory of AI where the AI learns from data without being explicitly programmed. This is in contrast to something like an expert system where there's different types of expert systems, but probably the easiest example to understand would be a series of if-then rules. So if you have some computer program where it says, if the sky is blue and if it's hot outside, then I think it's summer right now. That would be an example of an expert system. But with machine learning, we're not telling it any characteristics or rules that we want it to obey. Instead, we're feeding it a whole bunch of data, and the model is extracting insights from that data.
Yeah, that's amazing to me, and we don't understand many times, and we are using, and we don't understand many times how these things produce information. And one of the things that, for example, within generative AI, there's a lot of people using nowadays ChatGPT and Claude, and the way that they're producing their data is, as I understand, is what's the next best word possible, right? And
Mhm.
then because of that, then you create hallucinations. So, for example, it doesn't mean that everything that they're going to give you is real. And an example would be like side effects. And we talked about this on Friday. So if you say, what are the most common side effects of X medication? It might be that it doesn't look for that particular side effect, sets of side effects, but because usually you'll have very commonly a set of side effects that has nausea, vomiting, diarrhea, and headache, then it might give you that set of side effects for the medication that you're asking when it's really a hallucination and it's not a real thing, just because of the way that it's producing data. So for example, for your application, what type of AI are you using and how does it generate your data?
Yeah, so that's a great point about the hallucinations with the large language models. And that's actually a big reason that at CyDoc, we are not using large language models. So it definitely has led to some interesting conversations because, there's some people out there who are so excited about large language models that they get kind of upset if you talk about doing something with language that doesn't use them. But basically at CyDoc, we're using an expert system, and essentially it's tied in with this huge proprietary knowledge graph that we built that is meant to capture medical reasoning in a very explicit way. And the reason we chose to use this technique is because, first of all, it works really well for the particular application that the particular problem that we're solving. It's also fast and much more computationally efficient than a large language model. And then finally, it avoids these issues of hallucination or bias that you could see in a large language model. So we know that the system we've built is going to have consistent and trustworthy behavior, and that the notes it's going to produce are exactly reflecting what was the information that the patient put into this system.
Yeah, that's really important. And then you mentioned bias, and bias is has to do a lot with the type of data, your data set. And that's something that you're very passionate about. And I think anybody who's involved in this should be cautious about, in all the sense of the word, like that's good data produces good results. Tell us about building your data set, which I know that you're a super expert at doing.
Absolutely. So building data sets is really key as a first step before you tackle something with machine learning. And it also tends to be tons of work, a lot of times, a lot more work than people may have anticipated. So I can just briefly talk about three kinds of data sets that may be particularly relevant for a medical audience. So that would be kind of tabular data that you would pull out of an EHR, text data, and image data. So if you're talking about tabular data, a lot of times this would be things like diagnosis codes or procedure codes. And even with something like that, which maybe on the surface it seems like it would be simple, you still have to do a lot of types of cleaning. So for example, ICD codes have, so much granularity. Maybe you have like 100 codes that all have to do with diabetes and different ways that there could be complications and whatnot. But if you're going to train a model, it's really helpful to be able to convey to that model that, hey, all these codes have to do with diabetes. So a lot of times a helpful thing to do is to map these ICD codes onto something called CCS codes, or clinical classification software codes. And those are kind of broader umbrellas that will help the model understand, all these ICD codes here, they actually all have to do with diabetes, say, with or without complications. And then you can do other kinds of things like for medications, maybe there's 20 different brand names, or if you're talking about something like warfarin, maybe 50 plus different brand names, and they're all the same active ingredient. So it's helpful to have a step where you map from the name of the medication to the active ingredient. Because what you really care about is like, what is the chemical that the patient is getting? But if you just feed in brand names, you're not necessarily conveying that information to the model. So there's a lot of different steps that are involved in cleaning tabular data from medical records. I did write a blog post about it at some point if you want to get into the nitty gritty. And then if we're talking about text and images, there's different kinds of considerations there. So with text, it depends on the type of model you want to use, but a lot of times you have to do kind of standard processing of the text to do things like, maybe your model wants everything to be lowercase, or maybe you want to get rid of some punctuation. There's a lot of those kinds of processing steps that can take place. Also, if you want to only use certain parts of the text, you have to deal with, how are we going to chop it up and pick out the parts of the text that we want. And then on the imaging side, if we're talking specifically medical images, those are stored in a file format called DICOM. And there's quite a bit of work that needs to be done to translate that DICOM format into a format that can be consumed by machine learning frameworks. So for example, TensorFlow and PyTorch, they're really popular frameworks for building machine learning models, but those would want you to have something like a NumPy array as your input file format. So you have to do some work to translate there.
So if I wanted to, I want to build a program. Let's say I don't want to build a program right now, just as an example. I want to build a program, and then I need to gather data for that. What's like the minimum amount of recommended data? Because the reason why we're seeing an explosion of AI is because we didn't have that much data before. Now we have the collections of the EHRs that we have right now. Now we have the programming. We have now the computer processing power to be able to do all these things. But is there a number of data or something that you guys say, you know what, this is the minimum that you need that's accepted as a unit in the AI world to be able to produce this program, just even for what you have, for the type of application that you have?
Yeah, so this is, I think, one of the first questions that everyone asks whenever they're starting out a project. And the honest answer is that unfortunately, there is no existing rule that can tell you how much data you need, which is a very useless answer. I mean, I remember asking that question to people and having them say that to me and thinking, well, that's completely unhelpful. So in an effort to be more helpful, I can talk about just some rough heuristics that I have found from my own experience, but these are definitely not rules. So for something where the type of data that you're feeding in is something you would format in a table. So for example, like what diagnoses someone has, what procedures they've had, medications they've taken. If you can format in a table, then, and if the task you're trying to solve has a pretty clear relationship between, what you're putting in and what you want to predict, then maybe on the order of a few hundred examples would be enough for you to start seeing some okay performance. Sometimes you may need on the order of a few thousand. If you get into text, then that completely depends on what it is you want to do with the text. So if you're trying to do something like generative AI, something like ChatGPT, then you need really huge data sets before you start getting the sophisticated kind of output that you would see with something like ChatGPT. And it's trained on enormous data sets and costs millions of dollars to train the model. If you're trying to refine an already trained large language model, then you might be able to get away with on the order of hundreds or thousands of documents, depending on how long they are and what exactly you're trying to refine it to do. If you're trying to do some kind of text classification where you have, like, say, a tweet, and then it has some kind of label, maybe, happy, sad, or political, not political, something like that, you could potentially get away with a few hundred to a few thousand examples. And then if you get into images, with one of the big projects I've worked on in the past, which was during my PhD, we were focused on 3D medical images. And with that project, we were taking CT scans and predicting multiple abnormalities from them. On the order of 3,000 scans, you could see performance that was around like 60%, 70%. If you then got up to 30,000, 35,000 scans, then for some of the abnormal findings, the performance would get up to like 99%. So there's kind of there's all these trade-offs, and how complicated is your data? How difficult is the task you're trying to solve? And what performance do you need to get in order for the model to be useful to you?
Something I'm thinking about talking about data is like, who owns the data, right? And there has been a question like if patients should be notified that their data is used before, like whenever you go to the hospital, if you're like and I don't know that the consents, I'm guessing that the consents already covered this when you go to a big academic hospital where you say, your information may be used for research, and why not, so that should be covered there. But I can imagine if I have an idea of, as a physician and entrepreneur, I have an idea to do this thing for patients, right? And I don't have access to data. Is there a place where I can go and purchase data? Is there a black market of medical data happening right now? Or, you go behind the scenes and you pay somebody for all this data to, how is that happening for that physician who doesn't have the connection with an academic center, or who doesn't own, if they went to the radiology center? Is there a process for those guys to gather their data, or they just have, affiliate with one of these institutions and then gather the data in that way?
Yeah, I think that's a really good question. I certainly hope that there is not a black market for medical data, but I mean, given the world we live in, if someone will pay money for it, there's probably someone selling it. So maybe that's out there. I'm not sure. I definitely would not recommend it. I think probably there's a couple options. I think it depends on what is the type of problem that you want to solve. So if you want to do something with, well, I should say, first of all, there are quite a lot of publicly available data sets out there, but the catch is that a lot of them cannot be used for any commercial purposes. So if you wanted to use them to, say, start a company, a lot of times they wouldn't be a good choice because the licenses specifically say it's only licensed for non-commercial use or only for research or educational use. If you're just interested in doing like a research project or kind of getting your hands wet or starting out with something, then there's tons of medical data sets out there, and you can find them on a variety of different websites. So a couple that come to mind off the top of my head are Zenodo is one. Zenodo has a lot of different medical data sets on it. That's Zenodo. And then PhysioNet also has a lot of data sets on it as well. And at some point in my life, I put together a list of websites that had medical data, but those are the two that come to mind now. If you want to build something that there's no data set for it, which actually happens a lot because there's kind of endless permutations of ways that you could pick data out of an EHR, then I think finding a collaborator at an academic medical center is probably going to be your best bet. You probably don't personally have to affiliate with them and work for them, but if you have a collaborator who's there, then through that kind of collaboration, you could probably gain access to data. And then the other option would be, if the type of data you need is something that could be collected through, say, a survey, then you could try kind of initiating that yourself. So you could try designing the survey and then giving that to a certain patient population and collecting the data that way.
So, thinking about the experience, because physicians we don't want to lose our jobs, right? And we want to keep diagnosing and treating. I don't know that there exists a particular paper. I don't know if you're experienced, you've seen something that says how much data we gather as physicians throughout our training and through our experience at different, 1, 5, 10 years, whatever it is that, down the road. After starting practicing versus the amount of data that you would be needing as a minimum for these models to compare to what a physician is capable of doing?
Yeah, I think it's a very interesting question. I'm not, off the top of my head, I'm not familiar with research that has tried to quantify what that number is, how much information doctors are exposed to and how much they synthesize and integrate over many years of training. But I think something that's interesting to consider is that although these large machine learning models do get better and better performance with more data, there's other factors, I think, that are super important in determining whether it is appropriate or safe to use them. So, even if you had a model that had high, ostensibly high performance overall for, say, diagnosing something or maybe predicting some kind of treatment, you have to really get into the weeds, in my opinion, before you could in good conscience try to use it for anything. So one piece would be to break it down by not just overall performance, but how is it performing for different groups? How's it performing for different genders or different races or different ages, and make sure that it doesn't have hidden biases, which, it almost certainly does. If there were not techniques applied to try to mitigate bias, it probably has some biases and that need to be fixed. And then I think other aspects of that are, there are things that people are good at that I think it's going to take a while before AI or potentially embodied AI, if you're talking about like robots, would be able to do. So even something like giving someone a vaccination or listening to their heart or just doing a physical exam. Like, I don't think there's a single robot out there that could do a physical exam on someone. So there's all of these other elements that are part of practicing medicine that really AI is a long way off from being able to do. And I also think there's kind of this ethical layer of like, if you're sick, do you want a machine to be taking care of you? And I know for me, like, if I get sick, I want a person to be involved. I want people to take care of me, human beings. Humans know what it's like to be sick, and humans know what it's like to be alive. And I think that patients want to have a human connection. So if we ever get to a point where there's AI out there, along with, robots out there that have the kind of mental capacity or fine motor skills that you would need to technically deliver medical care, at that point, I think probably any job in the world could be automated, and it'll be a really interesting societal dialogue about sort of where would humanity go from there. If every single thing that people do can be automated, then what are people going to do? And I don't know the answer to that question, but hopefully we'll always have ways for people to be doing meaningful work, because otherwise we get into dystopias.
Well, and that's a great comment coming from somebody who has studied this and who's really in this environment and going to all these conferences and connecting with so many people around the world. It's like there's some things that are really going to be very useful, things that might be substituted, but the level, the capacity that we have nowadays of computation is not right there yet to be able to substitute us from your point of view. So it's really something that is reassuring. We don't know when or if right now at this point. That's something that we even want to explore. And I don't know that we have yet the protections for everything, if that was going to happen, but that's a different topic on its own. Now, in your company, you have built your data sets, you are already with a product that's released, and then we're growing a company. Let's talk about the ways to grow a company from a basic point of view. One of the things that we think about when we're funding large projects is that we talk, to either different types of investors. But something that people are not necessarily really aware of is the SBIR. So you are applying for that. Tell us about that process. Tell us what it is and how it differs from other types of investing, like angel investing.
Absolutely. So yes, I am currently preparing an SBIR application, and an SBIR is, I believe the number associated with it is like R43 or something. Like if you've heard of an R01, I think the SBIR is phase one is an R43. You can check me on that. But in any case, it's a grant, and you can get it through a bunch of different subcomponents of the government. So the one I'm applying for is a National Institutes of Health, NIH SBIR, and there's also SBIRs through the Department of Defense, through the National Science Foundation. My understanding is that every kind of subsection of the government is required to have some percentage of the budget that goes towards these grants, and they're specifically to fund small business innovation, small business R&D, developing really novel or innovative products, and getting funding that way. And they're divided up into multiple phases. Right now, I'm doing a phase one application, and those are for on the order of $200,000 to $300,000 in grant funding. It's a grant, so it's non-dilutive. They don't take any equity. They just, they give you the money, and then you have to carefully account for how it was spent and make sure that certain, the right percentages of it are going towards the R&D activities. And then there's a phase two where if you successfully complete phase one, then you can apply for phase two, and that's on the order of $1 million in grant funding, or I think in some cases more than that. So it's a really exciting opportunity for getting non-dilutive funding from the government. And in the health space, the NIH has all of these different centers and institutes that cover so many different application areas. So there's huge opportunities there for getting started with a small business and getting some funding through the program.
Yeah, I have friends who are in academics who use this. They don't use this section, but they have a lot of connections who have used them to start their own businesses, and they didn't have to really fund through somebody that they had to give equity in their business. So tell us about your consideration with going through an SBIR versus an angel investment or any other different type of investments.
Yeah, absolutely. So if we talk about, angels versus VCs versus grant funding, there's pros and cons to all the different options. So angel investors would be high net worth individuals who will invest their own personal money into a company, and VCs are individuals who are administering a VC fund. So the VC firm will raise a fund, and then the VCs will allocate that in investments to different companies. And angels and VCs have different they target different kinds of companies. So they'll target different stages of companies. Some of them will target pre-seed, which would be like you have an idea or an early prototype, but you're very early on, and all the way down to much later fundraising stages where it's a big company with lots of customers and it's trying to grow faster and faster. So they have different stages they target, and then they also oftentimes will have different, not always, but often different topic areas that they will target. So there might be some angels or VCs who are specifically focused on healthcare, or maybe some that are specifically focused on fintech. And anyway, you can go through this. Basically, if you go online, you try to find angels and VCs, you can narrow it down according to the stage of business you are and what your business is working on the grant. And then the big thing with angels and VCs is that in some form or another, they will take a percentage of ownership of the company in exchange for their investment. Also, their timeline tends to be around 5 to 7 years. Ideally, they would like to see some kind of exit. Either you sell your company to a bigger company, or you go public, or something where they can essentially collect the money that they made off your investment. And then on the grant funding side, with the grants, the process of getting a grant is pretty different from pitching. So you have this, huge application that you prepare that has these different formal sections and all these rules about how you're supposed to put it together. And then if you get the grant awarded, you'll receive the money, not in exchange for equity, but kind of in exchange for very detailed accounting of how you spend it, and making sure that in the case of an SBIR, that it's being spent on R&D activities rather than, say, on marketing.
That's awesome. So right now, in your case, you're going to be doing R&D. Can you tell us a little bit about what you're going to be, your topic will be?
Sure. So as I had very, very briefly touched on earlier, the overall goal of my company CyDoc is to build this AI native electronic medical record. So that's going to be the topic of our application. And basically, there's a couple different pieces that have to come together for that. So one big piece is making sure that the data in the databases that we create is ideally suited not just for clinical use and being able to retrieve individual patient records, but also is arranged in such a way that AI models can be trained off of that data without having to spend months or years cleaning it beforehand. So our initial application is going to be geared towards that AI native EHR as our product, and some strategies that we're planning to develop to make that possible.
That's great. That's awesome. So tell us, where should physicians be going? Any meetings these days that you're recommending for physicians to go and gather and learn more about how to connect and how to contribute in this world of artificial intelligence in healthcare?
Absolutely. The first conference that comes to my mind is Machine Learning for Healthcare, or MLHC. That's a conference that's entirely focused. I mean, from the title, you can tell it's Machine Learning for Healthcare, and that's the whole focus of the conference. So that could be a good option. There's also a conference called CHIL, CHIL, and I'm forgetting what the abbreviation stands for, but that's another healthcare machine learning conference. And then a lot of times, kind of machine learning focused conferences like NeurIPS or ICML will have within them, they'll have healthcare themed research work that is being presented. There's also the health conference, which is HLTH, and that one has a lot of people in industry who are working on exciting health tech, some of which is health AI.
That's great. So now that you've told us about those conferences, let's talk a little bit about something that physicians don't really know about, which is Archive. What can you tell us about Archive?
Absolutely. So Archive is it's a preprint server. It's hosted by Cornell University, and it's a place where researchers in machine learning and AI and a variety of other different fields will post their research papers pretty much as soon as they're ready to be shared. So if you're interested ever in looking at sort of bleeding edge healthcare AI research, a lot of those research papers will be put on Archive before they get formally published in a journal. So it's a really great way to get kind of a sneak preview of what is it that people are working on right now in the healthcare AI space. And also because you can see who the authors are, you can get a sense for who's working on it. And if you see something that you think seems really cool, a lot of times the papers will have the email addresses of the authors on them. So it never hurts to just send them an email and say, hey, do you have any future projects coming up where I could collaborate with you?
That's really a great way. I really didn't know about Archive myself. And one of the things that we've been telling physicians is that they really should get involved. So if you're ahead of the game, just looking at the things even before they're published, Archive would be a wonderful way of doing that. And also getting your data set, getting your collaborations aligned, and then giving validation to the things that you're thinking, your ideas, and also helping the system, helping the process, so that you can get involved. That's amazing.
It's a really great resource. It's the spelling is a little bit unusual. It's ARXIV. So if you're going to do a Google search for it, you want to search ARXIV, and then you should find it.
That's great. Well, thank you. You've given us so much. I'm so excited that you have already released your product and that you're now growing your company in such a way, and you have so much passion to help physicians really connect with their patients, because when you're spending less time documenting, you're really spending more time with that patient and giving them the quality time that they came for. So thanks for doing that for our physicians. Good luck in everything that you do. And once again, if physicians or anybody else want to get it, a hold of you, how should they do that?
Feel free to send me an email or even call me. So my email is my first name, Rachel, dot my last name, Draelos, at CyDoc.ai, which is CYDOC.ai. Or you can just give me a call or send me a text at 425-802-0575.
Okay, there you go, guys. She's available, and I wish you all the luck. And I know that you're not going to need luck because you're doing so well on your own right there, and you have a great team. Thank you for being here with us today.
Thank you so much for having me.
See you then. Well, guys, that was it for today. I hope that you had a lot of fun. I certainly did. I learned a lot from Dr. Draelos. If you actually want to get a hold of her, you can go to CyDoc.ai. That is C as in cat, Y, D as in dog, O, C as in cat.ai, CyDoc.ai, to reach Dr. Draelos. I hope that you have a wonderful time again. Please subscribe to our YouTube channel as well. It's called Maxallure Mastermind, MAXALLURE Mastermind. Our website, visit it, is maxallure.com, and give us 5 stars on this podcast. Share it with your friends and family. We'll see you then. Thanks. Bye.
Please remember that Design is not providing specific financial, medical, or career advice. Our only intent is to stimulate your appetite for growth by sharing our experience and those of our speakers, coaches, and guests. Your personal growth and success will be unique to your circumstances and your hard work. We sincerely hope you enjoyed the show and look forward to seeing you next week.